So let's pick up with our DHCP configuration. We've just set up a pool. Now let's go over to the DHCP bindings. And this is where we could specify a static DHCP address, or what most DHCP implementations call a DHCP reservation. We won't actually specify one here, but we can say this is the name for the binding. Here's the IP address we're going to assign and the mask. We can identify it by either the hardware address or the client name. And once we do this, anytime the DHCP server sees this MAC address or this hardware address, it will hand out this IP address and this mask. Obviously, we don't have any of those, and so we don't have to use that. So now, if we're lucky or good or both, we can go back into our GNS3 and we'll fire up this client PC, start it up, and we'll see the console here. And I'll pause while it boots up until we get to the desktop, and we'll validate that we actually got the DHCP address that's in the range we expected. So with the magic of editing, we're now in our Windows XP machine. Here's our Ethernet adapter. You'll notice we got the DNS suffix lab.local. We got 10.10.1.50. We have the right subnet mask, but we don't have a default gateway. That was obviously a misconfiguration on our part, so let's go and fix that, and let's release and renew the address. So let's go back into the Secure Device Manager. There's our pool. We can click this button here to see DHCP pool status. There is the IP address that was leased. So let's edit this and put the default router of 10.10.1.254 in here. Delivers those commands to the routers, and I'm going to go ahead and write the config using SDM. And the reason this didn't work the way we expected it to is because this import all option was left to true. And so since we had import all checked, it imported nothing because we didn't specify anything. So if we do ipconfig release, then we do ipconfig renew, we should get everything including a default gateway, and we should be able to ping our DNS server that we specified. So now we should actually be able to ping 10.10.1.254, which is our default gateway. So we'll do ping 10.10.1.254. And there's our default gateway replying. Now we can't ping out to the internet yet because routing says that the internet doesn't have a route to get back to us. We're going to configure NAT here in just a few videos, but first let's go and look at the router CLI and see what commands are available to us out here in the router. So if we do show run, let's see what commands actually got put on the router from all of this. So there's DHCP excluded address, there's our exclusions, and the reason why we have exclusions in here is because that's how it's handled in the iOS. You tell the router, here's your entire pool of addresses, and you exclude these from being handed out via DHCP. So that's your first difference that you see configuring it in the iOS versus the SDM. So there is our IP DHCP pool lab pool. There's our import all option. Again, we could have left that unchecked. There's our network, our domain name, DNS server, and default router. And really, if you're going to configure it in the iOS, that's all you really have to have. You can get fancy with the options to say, if you've got an IP phone and you need to register with a call manager server or a voice over IP server, then you can set an option in the DHCP to tell the IP phone where to go register. You can set up IP helper addresses if your DHCP server happens to be on a different subnet. Let's look at some of these show commands. We'll do show IP DHCP, and we have a few options here. We'll do show IP DHCP pool, and we'll do lab pool. And it is case sensitive. I forgot about that. So now we get a little more information here in the iOS than we did in the SDM, obviously, because the iOS is more of a utilitarian interface. So there's the utilization mark, high and low. It shows 100 and 0, showing that we've basically had no activity. Those utilizations are in percentage, so it says that we could go all the way up to 100. We could go as low as 0. Tells us how many addresses are in the pool, how many are leased, how many are pending events. So if you have a very busy DHCP server, you might see 5 or 6 MAC addresses pending an event, a renewal or a release, or so on and so forth. And it tells us that there's one subnet currently in the pool. So now we have successfully configured DHCP. Hang around in the next video, and we'll configure NAT using the Secure Device Manager, and we'll verify that we can actually get out to the internet through our NATed address. For now, this concludes our discussion of verifying DHCP.